Hello everyone, Patrick Clayton here with another discussion question. For this one, we're going to be going over graphing a function, negative 2x minus 12x minus 10, which is a parabola. We're going to need to find the vertex, the axis of symmetry, the domain, range, and any intercepts. So at the start of this problem, usually we'd start by finding the vertex. There's a couple ways we can do that. We can either convert this into vertex form using completing the square, or we can use the vertex formula. I'm just going to go ahead and I'll start with the vertex formula, which is the x value of the vertex, h, is equal to negative b over 2 times a when we have the equation in the form ax squared plus bx plus c. A, b, and c are the coefficients of those terms, so our a in this case is negative 2, our b is negative 12, our c is negative 10. So for our case here, negative b would be 12, so h would equal 12 divided by 2 times a, which would be 2 times negative 2. So that gets us 12 over negative 4, which gives us negative 3 as the x value of our vertex. Now when we're using the vertex formula to find h, in order to find k, we have to plug h back in to the original equation as an x value to find the corresponding y value, in this case k for our vertex. So if we go ahead and do that, we do negative 2 times negative 3 squared minus 12 times negative 3 minus 10. This gives us 3 squared is negative 3 squared is 9 times negative 2 is negative 18. Negative 12 times negative 3 is a positive 36, and then minus 10. And so that gives us 36 minus 28, which is 8. So the k value in this case, which is the y value of our vertex, is 8. So now we know hk, our vertex, is negative 3, 8. So that gives us a point to start with on the graph. I'm not going to do the graph yet, but this is the solution for the vertex, which was the first thing they asked us. Next, they ask us for the axis of symmetry. So the axis of symmetry of a parabola is the line that splits that parabola directly in half, the left arm from the right arm. And that is always given by the formula x equals the x value of the vertex. So for our case, x equals, and then our x value of the vertex is negative 3, so it would be x equals negative 3 is our axis of symmetry. So that would be our second portion solved there. Next, for the domain, whenever you're dealing with a standard parabola, nothing restricts the domain here. There's no denominator. There's no even roots. Nothing that would say any x value couldn't be used. So for your standard parabola, the domain is always unrestricted, which means negative infinity to infinity, and we'll double check that when we get the graph, but that's universally true for standard parabolas, parabola functions. The range also it is pretty standard for a parabola. For a positive parabola, so a positive parabola would be one opening up. It's always going to be from, as we're going down up, the y value of the vertex continuing on to infinity. If we have a negative parabola, it would be from starting at negative infinity and going to the y value of the vertex. In this case, if we look at our first term there, what we have here is indeed a negative parabola. So we are the second scenario. So our range is going to start at negative infinity, and it's going to go to the y value of our vertex, in this case 8. And in this situation, whichever side the y value of the vertex is on, that is included in the graph. So that will be a solid filled in point y value when we graph it. As for intercepts, the y-intercept, we would plug 0 in. The x value at the y-intercept is always 0. So we're just going to plug 0 in to the original equation. And when we do that, negative 2 times 0 squared, that term's going to go to 0. The minus 12 times 0, that term is also going to go to 0. And then the minus 10. So we'll be left with, when x is 0, y is negative 10, and that indeed is our y-intercept. So that solves that. And then for x-intercepts, we want to set the initial function equal to 0. So when y equals 0, that's when we're crossing the x-axis, and that's where our x-intercepts exist, is on wherever we cross the x-axis. And for a standard parabola, you're either going to have 0, 1, or 2 x-intercepts. You'll have 0 if the parabola is either entirely above or below the x-axis. You'll have 1 if your vertex is on the x-axis, and if your parabola crosses the x-axis, you'll have 2, 1 on the left arm, 1 on the right arm. So for x-intercept, we are going to say 0 equals negative 2x squared minus 12x minus 10. I'm going to factor a negative 2. I'm going to divide everything by negative 2. Since they're all divisible by negative 2, which in this case gives me x squared plus 6x plus 5. So again, that's just dividing both sides by negative 2. 0 divided by negative 2 is still 0. Then we can factor this. X squared can only come from x and x. Second sign's positive. Oh, I'm sorry, didn't have that paper up high enough. When the second sign's positive, it means our signs and our factors are going to match, and they're going to match the first sign, so they'll both be positive. Factors of 5 that add up to 6. Well, there's only one factor set of 5. It's 5 and 1. So now we can apply zero factor property. We get x plus 5 equals 0, and x plus 1 equals 0. We solve that for both, and we get x equals negative 5 and x equals negative 1. Again, the corresponding y value is 0, defined by what we plugged in. So our x-intercepts are going to be the points negative 5, 0, and negative 1, 0. So in this case, we have two x-intercepts. When we go to graph this, we have our x and our y axes. So we graph the points we know. We know 1, 2, 3, 4, 5. We had one at negative 5, 0. We had one at negative 1, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we had one at 0, negative 10. And then we also have our vertex, which was at negative 3, 8. So up here, again, we can label all these points. And then we just need to draw our parabola. I'm a terrible artist, so should end up with a parabola that looks like so. If we want to put our axis of symmetry in there, we can as well. That's that line x equals -3. So this would be the graph of f of x equals -2x squared minus 12x minus 10. So methodically go through the steps. Sometimes students mix up which intercepts which, or finding the vertex can be an issue. Usually with the vertex formula, it's fairly easy. If you're trying to do the completing the square, it can be more difficult, and if you want to go over that, make an appointment with me. I'd be happy to show you how that process goes. But I'll give you an equation on the back here to try one out for yourself. If you'd like to post your solution in the discussion post. And so for this one, we want to graph function of x, 3x squared minus 6x minus 9, and again, find the vertex, axis of symmetry, domain, range, and any intercepts of the function. Good luck, and I hope you have a great rest of your day. Thank you. Bye.